Hello everyone, welcome to lesson 7-9 where we will be simplifying rational expressions. I know this is the last week of school and it's probably the last thing that you want to be doing, but one thing that we can, if we want to look at this in a positive light, we don't have to prepare for finals, so that's a good thing. And I'm not having you do a separate assignment. We are going to take notes on this. We will be doing the example problems together, and then you will be doing the practice problems on your own. My suggestion would be that after I do example number 1, you pause the video and you do practice 1. I will not be doing the practice problems on the video, so you can't check your answer there. However, I am offering 3 additional Zooms next week. So please read the Google Classroom post for this assignment. It gives you the days, the times, and the links to those Zooms. So if you would like to check your answers or just clarify anything, then we can go over it at that time. I will also be holding normal Zooms on Monday and on Wednesday mornings. So those will not go away. All right, so let's go ahead and get started. When we talk about simplifying rational expressions, you have already learned how to factor rational expressions. Now we're just going to simplify them like we would simplify a fraction. So we're going to use everything that we've already learned and then just basically cancel out the like factors that aren't needed. Okay, so let's see what this looks like on example number 1. Okay, my steps are very simple. Factor the polynomial in the numerator. Factor the polynomial in the denominator. Simplify. That's pretty much it. So in looking at example 1, I know that I cannot factor out my numerator at all. It's as factored as it's going to get. Okay, so I am going to just leave that as x minus 1. Okay. And looking at my denominator, I can factor that. So what you're trying to do is you're trying to figure out the greatest common factor between 5x and 5, or negative 5. Well, it's 5. Now remember, if you need to work out factoring expressions, by creating that factor tree and doing all that, you can. But just as a reminder, and I might do this with one that's a little bit more extensive, but we have 5x and its factors are 5 and x, and then we have negative 5, its factor is 5. So the greatest common factor that they share is 5. Okay, that's how we get that. So what I'm going to do is I'm going to take 5x here and divide it by 5, and then I'm going to take negative 5 and divide it by 5, okay? So 5x divided by 5, our 2 5's cancel out, and we're left with x over 1 or just x for this one, okay? And then 5 over 5 changes to 1 and 1, so minus 1. So what we have here is our greatest common factor of 5, and then in parentheses, we have this term right here, x minus 1, okay? So we just factored our expression, and we got this. And now we are going to simplify. So since x minus 1 is over x minus 1, okay, if we were to write that out, x minus 1 over x minus 1, well, that just equals 1. Just like 3 over 3 equals 1, 105 over 105 equals 1. Any term over itself always equals 1 and can be simplified, okay, to a 1. And then you really don't need that 1. So the way that we do this is we can cross these 2 out because they equal 1, and we can replace them with 1 and 1 if we want, but we don't have to. And so then we write out our final answer, which is 1 over 5 times 1, which is 5. And that is our answer for this problem. Practice number 1 is very, very similar to example 1. So at this point, I probably pause the video and just refer to this example as you do that one, okay? Great, let's go ahead and go down to example 2. And looking at my numerator, 2x and 5 do not have any common factors. So I'm just going to write 2x minus 5, okay? Now 6x minus 15. Those two numbers, 6 and 15, both have a common factor of 3, okay? So basically what I'm going to do is I'm going to take 6x divided by 3 and negative 15 divided by 3, okay? So when I simplify these, this cancels out and this becomes a 2, so I get 2x. Negative 15 over 3, 3 becomes a 1, 15 becomes a negative 5. So this is what will go inside the parentheses. Okay, so we factored the numerator, we factored the denominator. Now we're going to simplify. 2x minus 5 and 2x minus 5 cancel out. They both basically become 1s. So we can write our answer as 1 over 3. And that's our final answer. Very similar to the first example, just the numbers are a little bit bigger, okay? Practice number 2, again, is very similar to example 2. Okay, let's go to example 3. So in looking at this, I can see that my numerator can be factored. So the greatest common factor between 5x and 15 is 5. Okay, so I'll write that as 5. And then I'll start my parentheses. So 5x divided by 5 and 15 divided by 5. Okay, so with 5 x over 5, those cancel out and I'm just left with x, and then 15 over 5 is 3 and that's positive. So that will go inside my parentheses. Okay, now 45 can't be factored. I mean, it's just a whole number, so we're just going to put that here. But we can still simplify. Since 5 and 45 are both divisible by 5, we can divide them both and simplify. It'd be just like simplifying a fraction, okay? Just like simplifying, let me turn this around, 5 over 45, okay? You would divide them both by 5, the greatest common factor, and you would get 1 over 9, okay? So that's really all that we're doing on that one. So 1 and 9, okay? So when we write this, we don't have to write the 1 on the outside of the parenthesis because 1 times anything is that, you know, is what that is. So 1 times x plus 3 is just x plus 3. So I'm going to write x plus 3, and then I simplified that down to 9, and that is my final answer. Now, one thing you need to understand is that some of you are looking at this and thinking, okay, well, 3 and 9 can be simplified also. Yes, they can. But when we're looking at rational expressions, x plus 3 is in parentheses. It is its own term, okay? So if, say the x was 6, 6x plus 3 over 9, okay? Then we could simplify all 3 terms by 3. But since our answer does not have a term that can also be simplified with 9, then we can't simplify this any further. So I hope that made sense. Let me say it a different way. If both of these terms cannot be simplified with the denominator, you can't simplify it. Both of them need to be able to be simplified with the 9. Okay. All right. If you need more clarification on that, just come to one of my Zoom help classes. Okay, so at this point, you'll want to look at practice number 3. Okay. And I'm going to move on to example 4. Now we're getting into problems where both the numerator and the denominator they are factorable. Okay, so if I look at 2x squared plus 2x, I can see that not only a 2 is a common factor, but also an x. So I'm going to divide them both by 2x. So if I take 2x squared and divide that by 2x, and then I take 2x divided by 2x, okay, I can get my simplified form. Now, one thing that I saw on where you were multiplying polynomials, a lot of you, when you came to something looking like this, you didn't put anything. You basically made it a 0, but it's not, it's a 1. So please make sure that when you are factoring out, that if there are 2 terms here, there should be 2 terms in the parenthesis. So the 2's cancel out here. 1x cancels out and 1x cancels out here, because if we do x to the second power minus x to the first power, so x to the second minus 1, you just get 1. So this becomes a 1. So we have factored this down to x over 1, or just x, okay? Now, 2x divided by 2x is 1. So they cancel each other out, but they still are 1. So this would be a plus 1. And it's plus because that's what we're dealing with here, addition. Okay, so when I rewrite this, I end up with my greatest common factor of 2x times x plus 1. And that was your numerator. So now we're going to factor out the denominator. With the denominator, the greatest common factor is 3x. So I take 3x squared over 3x, and then 3x over 3x. And when we factor them out, this becomes x, and this becomes plus 1. So I have my greatest common factor of 3x, and then x plus 1. Okay, so now that we've factored them out, which is review, we can simplify our rational expressions. So our x plus 1s can cancel out here, okay? And something else can factor out. And some of you miss these little factorable moments, I call them. But the x and the x will cancel each other out, okay? So I can get rid of those. So now my final answer here is 2/3. So that's how you factor ones that look like this. Now, when you come over here, you are going to have to factor, your greatest common factor is going to be a 5x for the numerator and a 3x squared for the denominator. Just a little bit of a hint for you on that one. Okay, moving on to example 5. All right, so in example 5, again, this is a little bit different again. We can factor out 2x minus 8. The greatest common factor is 2. So 2x divided by 2 and negative 8 divided by 2. Okay. So when we do that, we get rid of this and we get rid of that. Okay, so x minus 4. So when we write the numerator, our greatest common factor is 2, and then we factored it out to x minus 4. Okay. Now, some of you may be looking at example 5 and you may be thinking, okay, I don't know what to do with that. Well, if you remember back to factoring special case polynomials, it was, I think, 7-6, maybe 7-7. We talked about perfect squares, okay? So in looking at this, I know that x squared is a perfect square, and I know that 16 is perfect square. So if I square root x squared, I get x. And if I square root 16, I get 4. So what I end up with after I do this is x plus 4, x minus 4. You remember that? So another way you can look at this is you can say, okay, what are factors of 16? Okay, if you did the x, okay, we take 16 times 1, or negative 16 times 1. And then we don't have that middle term, so we can say that it's 0. Okay? So what two numbers multiply to get negative 16, but add to get 0? Well, 4 times negative 4 is negative 16, and 4 plus a negative 4, or 4 minus 4, is 0. So you could always do it this way as well. So we have x plus 4, x minus 4, okay? All right. Now we can simplify. So I can get rid of these two. They cancel each other out, my x minus 4s. And I am left with 2 over x plus 4. Okay. And you could do the same thing for practice 5. Okay, let's go on to the second page. We're going to look at example 6. We're halfway there. Okay, so with number 6, we're going to factor the numerator like we have been, and then the denominator, we're going to use the x and find factors of negative 6 that add up to a positive 1. Okay, so with this one, 3x minus 6, my greatest common factor is 3. So 3x divided by 3 and negative 6 divided by 3. So when I write this, my greatest common factor is 3. And then I simplify these and I get x, and then 3 divided by 3 is 1, 6 divided by 3 is 2. So x minus 2 will go in my parentheses. Okay? All right, now we're going to go back to factoring trinomials with a leading coefficient of 1. And we just can create our x here. So negative 6 times 1 is negative 6. And then our middle term is a 1x. So we'll put 1 right here. And factors of 6 are 1 times 6 and 2 times 3. Now at this point, I know that one of my numbers has to be negative. And some of you had a difficult time on the homework with this, trying to figure out which one was which. So this is a positive number. That means that the larger number of my two factors has to be positive. Well, in looking at this, I know that I'm going to have to use these two right here. And since 1 is positive and my largest number has to be positive, that means this one has to be negative. So let's look at this. Negative 2 times 3 gives us a negative 6. Negative 2 plus 3 gives us a positive 1. So that works. So on the bottom here, I'm going to have x minus 2, x plus 3. Okay. Now we can simplify. We can get rid of our x minus 2's, and we are left with 3 over x plus 3. And again, we can't simplify because this is considered one term. Okay. So example 6 is very similar. If you want to stop the video and try that one, I'm going to move on to example 6. Uh-oh. I think I forgot to, hold on, you guys are going to probably see my screen in just a second, but that's okay. Let's see, going down to 9 notes. I thought I reprinted these, but maybe I didn't. Oh yes, this one is different on yours. So yours is plus 15 and plus 5. I wanted to switch those when I printed it up because this one is slightly more difficult than this one right here. Okay, so x squared, oh, and this is plus 8x. Plus 8x plus 15 over x plus 5. X plus 16 over x minus 4, perfect. Okay, so now I can take this off and we can go back to our screen. Okay, now we have a numerator with a trinomial, so I'm going to use the x first on this one. So 16 times 1 is 16. And then our middle term is a -8. Okay. So I know that 4 times 4 is 16 and 4 plus 4 is 8. However, my 8 has to be negative. Well, in order for it to be negative with these two terms, I have to make both of these negative. So -4 plus -4 equals -8, and -4 times -4 equals a positive 16. So when I rewrite this, I have x minus 4, x minus 4. Now, typically we would put x minus 4 squared, but since we're simplifying them, this one we can't factor out any further. Since we're simplifying them, we're not going to do that. So I can get rid of one of each here. And basically we're left with a 1 at the bottom. So our answer is just simply x minus 4. Okay, let's, you can stop and do practice 6, or you can keep going with me. Example number 7, on this one, we have to factor both trinomials. So let's see what we get when we do that. 8 times 1 is 8, with a middle term of -6. And we'll do one at a time here. Well, I know that 2 times 4 gives me a positive 8. 2 plus 4 gives me a 6, but since this is negative, that means it has to be -2 plus a -4. And then -2 plus -4 gives me a positive 8. So when I write this, I'll have x minus 2, x minus 4. Okay, so now let's factor our denominator. -6 times 1 is a -6. I didn't write that very well. And our middle term is 1, so we have 2 times 3. And that's not going to work, is it? No. Well, wait a minute. Wait a minute. Yes, it will work. -2 times 3 is a -6. -2 plus 3 is a positive 1. Didn't we just do that one? I think we just did that one. Okay, so we're going to have x minus 2, x plus 3. Okay, so our x minus 2's can cancel out, and our final answer is x minus 4 over x minus 3. All right, our final example. Now this one, because our leading coefficients are not 1, we're going to have to also include the box in this one. So let's look at this numerator here. I'm going to do, so -8 times 5 is a -40. And we have a positive 6 here. Okay, so 4 times 10 gives us 40. So one of those has to be negative, and since this is a positive, that means my smaller one needs to be negative. Okay, and then we are going to do the box. Okay, so if you remember, our first term goes here, 5. Our last term goes here, -8. Then we have these two terms, and it doesn't matter which box they go in. Okay. And so 1 times 5 is 5, and 2 times 5 gives us 10. 1 times -4 gives us -4, and 2 times -4 gives us a -8. So that all works. Okay, so look how I'm going to do this. Okay, so this equals x plus 2 and 5x minus 4. Okay, so that's our numerator. Now I'm going to do the denominator down here. Okay, on the denominator, -2 times 3 is a -6, and our middle term is a 5. Okay, in this one, we're going to have to use 1 and 6. 1 times 6 is 6. 6 minus 1 is 5, but one of them needs to be negative, and it is going to be the 1. Since our 5 is positive, the larger number has to take on the same sign as this one. Okay, so now let's use our box. Okay, so we have 3 as our first term and -2. And then we have -1 and 6. Okay, so let's see here. 1 times 3 is 3. 2 times 3 is 6. 1 times -1 is -1, and 2 times -1 is 2. So x plus 2 and 3x minus 1 are our 2 terms here. So once we've done that, we can now simplify. So our x plus 2's will cancel out. And our final answer is 5x minus 4 over 3x minus 1. And with that, you should be able to do the last practice problem. If you have any questions, please email me or come to one of our Zooms next week. And I hope you guys are all having a great last week of school.